is a letter from the Ministry of Production thanking the firm of John Dickinson and Company for its efforts in the production of warlike stores in the war against Germany and Japan. It continues, "To have converted a large portion of your factory from paper conversion to engineering and to have produced with success a large range of engineering and other products required by the services is indeed a fine achievement." As the many and varied wartime products of John Dickinson's at Apsley Mills and Basildon Works pass in review, we're reminded of the immense effort made, not only in the teamwork of changing productive equipment to the needs of war in a race against time, but the efforts of each individual worker in turning from stationery production to acquire some entirely new skill. These specimens are representative of the thousands of such articles that poured out of the mills to add to the equipment of our forces and play a part in the immense events of those war years. In the Battle of Britain and the London Blitz, in the Desert Campaign, in Russia, in the Battle of the Bombs over Germany, in the landings in North Africa, Sicily and Salerno, in the daily battles of the little ships, on D-Day, in Normandy, Holland, and in Germany itself, and with the 14th Army in Burma and our Pacific battle fleet. Since 1804, when John Dickinson built his first machine, paper and the products of paper had been made on the site of Apsley Mill. Every morning at 8 a.m., some thousands of the workers of John Dickinson and Company arrive for work. Britain has a long tradition of craftsmanship, and Dickinsons have helped to make British goods known and respected all the world over for their value, quality, and workmanship. Converting paper into many forms of stationery is their contribution to the life of the community, and they're a happy family working on the most peaceful of trades. As our story begins, their production had reached the peak of perfection, with envelopes in an amazing variety of hundreds of sizes and qualities. Private stationery, nationally famous, such as Basildon Bond, Croxley Stationery, and the Lion brand series. Manuscript books and accountancy material for every purpose in the home, business, or school. And there were few printers and stationers to whom Dickinson cards were not familiar. The Tottenham branch factory, in addition to envelopes, made labels, carriers, and table stationery. An impressive output of artistry, craftsmanship, and manufacturing skill. Then came the day, September the 3rd, 1939, when Great Britain and the Dominions took their stand against aggression. Like all other great firms, John Dickinson and Company put on battle dress and turned over its factories to production of the essential goods of war. This story tells how a large business engaged in a peaceful occupation made a swing over to the needs of modern war, while at the same time work was maintained on essential stationery for industry and His Majesty's Stationery Office. As well as concentrating on new activities, the Dickinson workers had to be ready to deal with any emergency. In the hospital, manned night and day for the succor of the injured. As spotters, specially trained in the identification of enemy aircraft. As air raid wardens, watching for incidents during an alert. In the Dickinson Home Guard, which kept constant vigil day and night on the vitals of our factories. As machine gunners who manned their guns in seconds on the sounding of the siren. In the fire service, always on the alert to tackle any emergency. And on the fire float, ready to deal with outbreaks accessible only from the canal. But these activities were incidental to production. Almost at the beginning, it was found that many munitions of war could be made from paper, and Dickinson's, as a firm primarily utilizing paper, produced many of the articles urgently needed. But also they embarked on the manufacture of complicated and highly technical precision engineering products. Yet, throughout the long years of war, John Dickinson and Company endeavored to produce supplies of essential paper goods of normal kinds, with the aid of elderly workers, even pensioners, assisted by part-time housewives who, by their efforts, released their younger and more active friends for the new and heavier work. Will you come back with us to the Dickinson mills as they were in the war years and see a few of the different productions in this building, part of the largest envelope factory in the world? And here in the book department, which made every form of manuscript book for the home and commercial use. Notice the camouflage which hid Apsley Mills from possible air attack. In the card and board department, whose normal productions were pasteboard, ivory boards, cloth-lined papers, and printer's cards. In the packing supplies department, where every type of packing envelope was made. In the stationery department, the home of Basildon Bond and other writing papers. And in the foreground, the power station which supplies the heartbeat of Apsley Mills. In the envelope department, part of its management and staff form the special munitions department to make products very different from envelopes. During the anxious days of 1940, when the squadrons of the few shot down those of the Luftwaffe and turned away invasion from our shores, the life of their aircraft depended upon the little sparks which came from that small part of their engine known to all motorists as the sparking plug, 3 million of which were produced at Apsley. The manufacture of sparking plugs is chiefly an engineering job, the machining and assembly of the many parts which make up the plug, here seen in sections. Perhaps its most vital part is the insulator, standing alongside the plug, and we will see how it is made. The insulator starts life in the form of a powder, which after it has been dried to the correct consistency is pressed in molds and in a very short time emerges in the shape of an insulator. So great was the need for sparking plugs that this long row of girls was kept busy daily from 8 till 6 and was then relieved by other girls who carried on the work right through the night. Quite a change for workers previously employed in making envelopes. Next, the insulators must be hardened by a 6.5-hour journey through intense heat. Their progress through the kiln is so slow that the movement is almost imperceptible. Each insulator is tested for flaws with a 10,000-volt spark, but the high standard of skill in manufacture and the constant checking permits a few rejections. This department also undertook the manufacture of magnetos, and their success is recorded in this personal letter of thanks from Sir Stafford Cripps, then the Minister of Aircraft Production. This is the magneto fitted to the famous Bristol Hercules 6 sleeve valve aero engine, and it's shown here in sections. This magneto contains over 800 separate parts. And here are partial assemblies of some of its intricate components, all of which had to be machined to the very greatest accuracy. 14,000 complete magnetos were supplied through the combined efforts of a team of 250 workers, some of whom we see at work in this machine shop where once envelopes were stored. All these jobs require skilled craftsmanship, as any failure might endanger the lives of our airmen, and at every stage each part is tested. The tin hats on the walls are a reminder that war was never very far away. Now, let us look at some of this work in more detail. To follow every process would take hours, even days. But here is a girl handling the screw cutting on the rotor. The actual job is done by a single-pointed tool necessary for extreme accuracy. And this ingenious machine works automatically, cutting the teeth of the gear wheel. Various sub-assemblies must be made before the magneto can take shape. The nimble fingers of these girls are putting together the contact breaker, every part of which has been treated against rust and corrosion. And this girl is assembling the rotor, one of the most important parts of the magneto. All these parts and sub-assemblies are now built up into the finished magneto. And the outer case is screwed on. But will the magneto stand up to 500 hours of continuous work without attention? Each one, as it comes from assembly, is given an endurance test under conditions as technically severe as any they would be likely to experience on a flight to Berlin or Milan. Now we turn to the oil filter, which was so valuable in the North African campaign and in the Far Eastern War in protecting engines from the inroads of sand. Many messy jobs were gladly undertaken by the Dickinson girls. In this case, the center pipe of the oil filter is placed in the mold. As the flannel coat is not for warmth, it's wrapped round the center pipe to act as a base for the filtering material, which is poured in at the top, shaken down round the pipe, and finally pounded home. After baking, it becomes a hard but porous filter through which the oil will percolate while the dirt is retained, while one machine deftly presses on the outer case. This conveyor carried the 750,000 filters made at Apsley to the heavy presses for final sealing. The filters were then cellulose sprayed and packed. From the sands of the desert, we passed to the Arctic cold of Russia, to combat which these oil dilution valves were used to give easy starting or sudden boosting to aero engines in sub-zero weather. The oil dilution valve is built up in small, accurate parts, work in which the nimble fingers of women excel. Careful supervision ensures that each valve is produced to the high standard demanded by the Aircraft Inspection Directorate. And now something for the Navy. These are some of the 6 million projectiles which Dickinson's produced for the famous Oerlikon guns of the little ships which kept open our lifeline across the Atlantic. So urgent was the need that it was necessary to work day and night shifts continuously. For the manufacture of the Oerlikon projectiles, steel bars are fed into this lease-len machine, in which they are cut amid these whirling wheels into projectiles of correct length and shape, being ejected every few seconds into the tray from which this girl is picking them. You've heard of Mulberry and Pluto, but probably not about Window. Window was the code name given to the small strips of aluminium and paper foil thrown out by our bombers. Its purpose was to disorganize the enemy's radar defenses, and its use played a great part in enabling our bombers to fly freely over Germany. For the making of the window material, paper and foil are separately fed into this machine, in which they will be laminated with paste, so that the window material emerges at the other end of the machine and is wound into reels. Having been cut into sheets and sorted, the foil is slit into long, thin strips. Some are hand-folded into snake form for packing. For other wavelengths, the guillotine cuts the pieces into short, thin strips, which are packed into bundles for the RAF. An even finer strip than this was made, and known by the RAF as angel's hair. Many women at Berkhamsted, exempt from war work, volunteered to put in a few hours' work each day if Dickinson's could supply the premises. And so an old garage was taken over and fitted out as a temporary factory. Under such conditions was born a team spirit which helped to meet the ever-increasing demand for window.